Yeah, Spring Fence School. Thank you. All right, keep me on track because it looks like Barron County time is about 10 minutes slower than Muhlenberg County time. No, no, I hope not. Yeah, he's a tough act to follow. That's probably about the 26th or 27th time I've heard him since the very first presentation, and I always pick up something new every time. So it's always good to have multiple resources in a school like this. So, with that being said, to get started, I will make a disclaimer that there are as many ways to build fence as there are people that build fence. So, if I say something in here today or out in the field this afternoon that is probably the opposite of what you may have built fence on your farm, don't take offense to it because this may not be this is not the only way to build fence, and it's not the only right way, but there are some ways that are a little more effective than others. Is that a fair statement? As farmers, and I'm a cattle producer in Muhlenberg County, we're inclined to take shortcuts every now and then, right? And so, and we'll see a few shortcuts today, and Jeff has got some shortcuts, some good examples, but his fence, for the most part, is effective even with those shortcuts until it's not. So those shortcuts could get you in trouble someday, and if they do, you'll know where to go and look and change it. So keep that in mind. What are the shortcuts we can take? What can we get away with? And I guess most of all is why do we talk about what we talk about at the fencing schools? So what we have tailored to over the past several years of doing these in Kentucky and Tennessee both is you should be able to follow what Clay and I will talk about in the field and go home and build a fence and it meet your NRCS specs in the two states that he and I deal with. And is there anybody from Kentucky NRCS here today? Miss Swihart's here from Tennessee NRCS, and it's great to see her. So when you leave, if you follow these methods and tips and tricks, then your fence will meet NRCS specs in Kentucky. That's why we build it like we do. And again, this is not just something that Jeremy says or Clay says or Jody. This information is backed up by your engineers that work for UK and your engineers that are on the team at NRCS in Kentucky. So, electric fence, power fence, the first thing you have to keep in mind, it's a psychological barrier. Now, the fence that Clay talks about is a physical barrier. So that fixed knot woven wire, barbed wire, hinge joint woven wire, that is physically keeping animals from either getting in or out or both. With electric fence, we're talking about a psychological barrier. How many of you all in here have used electric fence before? Pretty typical for Barron County area. There's a lot of electric fence in Barron, Allen, Warren County. So of those of you that raised your hand, I'm assuming that every one of you have always had 100% good result luck out of your electric fence, right? No? Okay. That's pretty common too. And hopefully we'll uncover some of the reasons why maybe you haven't had such good luck over the years. The first thing you have to remember is electric fence, power fence is a psychological barrier. We learned several years ago that using, and we'll primarily talk about smooth high tensile as a permanent setting for this school. We'll get deeper into the temporary fence if you decide to come to a Kentucky grazing school that should be back on for next spring, so keep an eye out for that. So we talk about smooth high tensile. We learned that it was a great product to put up in the early 80s. Very economical, fast to put up, easy maintenance, and effective. Except for that first design that was brought here, mostly by extension in the 80s, was an electric or a non-electric 12.5 gauge smooth slick wire high tensile fence that was about 12 or 14 strands. about that far apart. Much quicker and cheaper and easier to put up than barber woven. And it worked great as a physical barrier, very flexible. Worked great for a physical barrier for about a month, maybe 2 months, when you started getting some slack into it. And then, as Clint says, cattle could creep through it. And once that started to become more popular with the high tensile in general, then we started incorporating some of the technologies out of New Zealand, where electric fence coincidentally was invented 82 years ago. We learned that we could take half as many or a third as many strands of smooth 12.5 gauge, electrify those, have an all hot fence, take the physical portion out of it, and make it a psychological barrier. And we found that in many cases, a psychological barrier is even more effective than the physical barrier. And we see this throughout the world, and especially in the U.S., almost every zoo or theme park that has animals, such as Animal Kingdom, every zoo you can drive to within a day's drive of Kentucky, will use electric fence, power fence, as the primary barrier to keep all these critters in and more. We designed those to be disguised as grass and weeds and vines and things like that, so you as a spectator at the zoo, you see the nice decorative cable fences, or you might see a moat, but you never do see the electric fence. So point being, if we can use the same concepts and almost exactly the same products to control these animals at the Nashville Zoo, Knoxville Zoo, Louisville Zoo, Disney's Animal Kingdom, then why in the world do we have so much trouble controlling these critters? Why is that? Anybody want to take a guess? Maintenance? Maybe installation? Maybe because the folks that are controlling these critters are farmers, and the folks that are controlling these critters are city of Louisville. That's true. However, I'll guarantee you on the gorilla exhibit at Louisville, we're not using pieces of water hose cut up for insulators. We're not using leftover Romex wire for the lead out cable to go from the 28 joule Energizer to the vines that keep the gorillas from climbing over the side of the exhibit. We're not using things that are made for residential that clearly say 600 volts, like Romex house wire will insulate against. Louisville Zoo's using products actually made for electric fence. They're not using rusty 17 gauge wire. So we can control these animals. We can control these animals very effectively. As a matter of fact, we can incorporate power fence into a system like this. This is a farm that the complete perimeters in electric high tensile, like many of the farms in Barron County. And it's cross fenced in single strand high tensile. And you can see here with the roll of poly wire, this person here is grazing stockpile fescue up until late December while his neighbors are feeding hay. That's some of the things we can do with electric fence if we incorporate it into a complete system. And by the way, that was a great year, and my neighbors kept threatening to come by and cut my hay field because it was going to waste. And I said, no, we'll just leave my hay field alone, and I'll show you why in about 2 months. And then they got real mad because they've been feeding hay that year starting in into September like they normally do, and I'm grazing stockpile fescue. So, when you're starting to plan, and Clay hit on planning and planning and planning and planning, and I'm going to hit on planning and stress how important it is. When you plan out your fence, get some graph paper, go to the FSA office, have them print you out your aerial maps. You can do it real easy now online if you have a computer and printer at home. Print out some aerial maps, draw and sketch around. Plan that out before you start setting posts. It's a lot easier to throw that piece of paper away and start over than it is to pull up a post and change your design. So when you're planning, how big of an area are you fencing? What are you keeping in or out? And keeping out is very important when we're talking about a power fence with sheep, goats, any of the smaller animals that are subject to predators? And is portability going to be an issue? And do you want to expand your fence over time? And if you do, then leave room for that and think about expansion while you're making your designs. Okay, if I'm going to put a cross fence in here later on down the road, do I want to configure my post spacing to match up with that, and so forth? So plan it out ahead of time. Remember that power fence, electric fence is a system, and just like any system, there are going to be multiple parts. If any part of a system fails, the whole system fails. If we take shortcuts on any one part of an electric fence system, then the whole system could fail. So you can see here that there are three basic parts to an electric fence system. Obviously, we're going to have the energizer, the hot box, the fencer, whatever you want to call it. You're going to have the ground system, which, believe it or not, is a system within a system. And then you have the actual fence itself, the insulators, cutout switches, wire, posts, etc., etc. And then there's a fourth kind of hidden component that joins your energizer to your fence together, and that's the lead out. And every one of these parts are extremely important. Probably the least important out of those four lines that are up there, the least important is going to be the energizer. You say, well, it's coming from somebody that sells energizers. Why would you say that? Well, currently the company I work for makes the largest energizer in the world. You can put the largest energizer in the world on a poorly built, cobbled together mess, and you're still going to have bad results. If those other two parts, and even the fourth, are not taken care of, the largest energizer in the world is not going to solve your problems. And you can overcome a lot of small things with power, and you see that every day right down the road here at Superior. Some things you can oversize your energizer and get away with some small things that have been overlooked. However, if you have a poor ground system, you're going to have trouble. If you have the absolute cheapest built fence system, component-wise, you're going to have issues. And if you're using Romex cable for your lead out and joining that copper wire and the Romex cable to your galvanized fence, you're going to have problems there. So all three of those parts have to work together. If any one part of that fails, the whole system fails. Energizer-wise, not going to spend a lot of time on this. If you are going to use any type of poly products for rotational grazing, always select a low impedance energizer. Almost every company now exclusively makes low impedance. Used to, you could find solid state. There's only a couple of companies that make a solid state energizer, and that's getting harder and harder to find because the technology is so old and it shorts out quick. But if I were to use a solid state energizer on polywire, the power stays on the line just long enough that if I have a blade of grass touching my polywire, it'll heat up and melt my poly in two, and then I'll have my polywire laying on the ground. The cows will be somewhere they're not supposed to be. So never use solid state for poly products, whether it's polywire, polytape, polynet, polyrope. Low impedance, when it was first invented, especially when it was marketed in the US the first time, it was called the unshortable electric fence. Now anything is shortable, but compared to the old technology, it was dang near unshortable. The low impedance technology basically means that the power only stays on the wire for about 3/1000ths of a second. Still going to tick every second, second and a half. You're going to hear a tick, but the time the power actually stays on the material is about 3/1000ths of a second. That's not long enough to heat up whatever's touching it and burn something into, cause fires. It's not going to, low impedance will not start fires in dry conditions, which is extremely important out west and equally as important here in the bluegrass, of course, but not quite of a risk year to year as it is in the west. So low impedance, what size? How do I compare? This is the $10 million question. How in the world do I know what to buy? Because companies are very good at marketing. We're good at marketing. Our competition's good at marketing. Their competition's good at marketing. So you've got all these different ratings that'll be on the box. Some will be in mileage. Some will be in acreage. Some will be in multi-wire, single wire. Some won't even tell you how many strands it's for. Then you've got the whole crazy concept of New Zealand versus U.S. ratings. There's several larger electric fence companies that are based out of New Zealand like we are that market the same Energizer in the U.S., in Europe, and in New Zealand. Same exact Energizer, same components will have different ratings for all three of those groups. So you go to New Zealand and pick up this Energizer that's called a AB1000, and the AB1000 in New Zealand may be rated for 30 acres if you convert it from hectares. So this may be 30 acres in New Zealand. You go to Europe, it may say 50 acres. You go to the US, the exact same Energizer, same packaging that's had a different label on it may say 250 acres. Now why is that? Probably because in the US everybody's in a rush to see who can have the biggest and best ratings, and there's a fine line between realistic and stretching the truth a little. Unfortunately, there's no magic formula that anybody can be held accountable for when it comes to being realistic. And most companies aren't going to try to stretch the truth intentionally, but there are some things we have to keep in mind. Considerations for mileage. Mileage is a fairly common rating you'll see on Energizers. Mileage is a great rating to use within companies. There is no standard for Energizers and mileage. Now there's some ideas, but there is no standard. So when you're looking at mileage on a package, it doesn't matter if it's this brand or any brand, think realistic. I'll be the first to tell you some of the mileage ratings on a Gallagher will not be realistic in some cases, even though it's going to be much lower than other brands from a rating standpoint on mileage. But let's go, so just travel with me across the river for a second in Missouri. Some places in Missouri, everything's going to be laid out in nice big square farms. Sections. A section of land is 640 acres. Square. A square section is 640 acres. Now you can probably think of some 640 acre farms in Barron County or Allen County, and they're probably not going to be square. But just for a minute, if it was square, if you took all those nooks and crannies out of it and stretched it out to a perfect square, there's going to be 4 miles around that 640 acres. So if I went to Missouri, looked on an aerial photograph and found one of those big nice chunks of squares and drove my pickup truck around it, I'm going to go 1 mile, 1 mile, 1 mile, and when I get back to the beginning, my odometer is going to say 4 miles. Everybody with me? So if I buy a fence charger that says it will do 4 miles, and some of those are probably going to cost about $49, a 4 mile fencer. If I go and I buy an Energizer that says 4 miles, I should, if I take that mileage rating literally, I should expect it to do 640 acres. A square 640 acres, because we know that the more square our perimeter is, if it gets perfect square, that's the least amount of perimeter. I can take 640 acres and have thousands of miles around it if it's long and narrow. So now we're at 4 miles. So jump a couple of steps ahead of that. You've all seen a 100-mile fence charger before. It says it right there on the label, 100 miles. By a little bit of math and a calculator, 100-mile perimeter is going to be 25 miles around each side of that big square. 400,000 acres. A square 400,000 acre has a 100-mile perimeter. Is that realistic? Should I expect to go spend $250 on a fence box and it do 400,000 acres? Probably not. So the point of this is compare within brands. If I'm looking at brand A and they've got a 100-mile Energizer and a 25-mile Energizer, there's a pretty good chance the 100 miles is going to be about 4 times stronger than their 25-mile. So We're going to be looking at something called joules that is measurable. Most every company will give a joule rating now. Joules are measurable. We can be held accountable. We can't just flat out tell a fib on something being 100 joules or 1 joule because it's measurable, not with a tester, but with an analyzer. Joules are like horsepower. So you say, okay, we got something measurable. Now that's great. Somebody's got to have some ideas on how many joules per mile. So we look at what the companies say. We can't really trust the companies because they just want to sell you something, right? Marketing, that's how it works. So we can look at companies, compare that to some of our neutral research organizations like Extension and NRCS. Surely they can come up with something, right? How many joules per mile? Well, let's take a look. You look at brand A or brand B in New Zealand versus US ratings, you're going to be somewhere conservative around 0.2 or 0.1 joule per mile. Now, they're going to say if you're going to do a mile of fence, you need to have a lot of joules, a lot of horsepower, possibly being realistic or possibly wanting to make sure that you're happy with your fence. And you say, okay, let's forget about the companies they market to us. Let's look at Extension and NRCS. So NRCS in Tennessee says about 1 joule per mile. Missouri Extension, who has done a lot of work with electric fence over the years and put out a lot of publications, they say, okay, yeah, Tennessee, they're right on about a joule per mile. We agree with that. But then you skip a couple of states and go to the far extreme, and California is like, we think about 0.2 of a joule per mile. And Minnesota's, yeah, that's about right. So nobody can agree on this. And unless Morgan and Josh can invent some kind of machine that an engineer can plug a fence charger into and it analyze something and just spit out, okay, this will do 4 miles of fence. This Energizer will do 10 miles of fence. Until they can do that, we're never going to know the answer, right, Morgan? Because it depends. How many joules per mile? We don't know. It depends. Depends on the length of the fence, how many strands, how much grass is on it, how much blackberry you've let get growed up in it, how many strands of old barbed wire from your neighbor's fence has fallen over onto it and caused it to short out. There's no good answer. Whether or not you use the wraparound tube insulators or a good strain insulator. So what we do know is when you buy power, you're buying joules and you're going to pay more per joule. You're going to pay more for horsepower, just like you do with a tractor. We can measure joules not easily, but we can also measure voltage real easily with a handheld voltmeter. There's all different styles, and some will have lights and some will have digital readout. And some will even tell you which direction to go for a fault. So we can measure voltage. Voltage is not necessarily directly related to joules. We can have a small joule energizer and a large joule energizer, and both of those on an equal setting may have the same voltage. Don't automatically think if you buy the largest energizer in the world that's 100 joules that it's going to put out 100 times more voltage than a 1 joule energizer that is just kind of a baseline starting point for 20 or 30 acres. It's not. No different. It's no different than having 2 tractors. One is 300 horsepower and one's 30 horsepower. I pretty well bet that a 3000 Ford is going to run 2100 RPMs with the throttle pulled back. And it's a pretty safe bet that whatever this big quad tire articulated orange thing is, that's 300 horsepower, is going to have about 2100 RPMs with the throttle pulled back on it too. Voltage is very similar to RPMs. We're measuring RPMs with our voltmeter. Just keep that in your mind for a second. So I can put a 30-foot disc behind both of those tractors as long as I keep the wheels down on that 30-foot disc. I can take a 3000 Ford and I can drive all around the neighbor, whoever Chris Chalk's neighbor is out here. I can drive around this pasture field with a 30 horsepower tractor and a 30-foot disc, as long as the wheels are rolling. Now the minute I hit the hydraulics and pick those wheels up, that 30-foot disc is going to cause that little 3000 Ford RPMs to drop from 2100 and just keep going until it finally belches out some smoke and dies. About the time my neighbor sees it, I've disc up his hayfield for no reason. So what I can do, though, I can take the 300 horsepower, the higher joule unit, the higher joule Energizer, load it with a 30-foot disc, load it with 300 acres worth of fence, and my RPMs, my voltage, are going to stay up at a manageable level. Folks at the university tell us that cattle and horses, we need around 3,000 to 4,000 volts to control them. Sheep and goats, 5,000 plus voltage. So I can keep my RPMs up at a controllable level as long as I have enough horsepower to pull the load. That's where your joule ratings come in. It's more horsepower. You're going to pay more for a higher joule Energizer, just like you're going to pay more for a higher horsepower tractor. Not going to get too deep in technical terms. A lot of the things that we speak about with electric fence can be correlated to some common concepts with water flow. For instance, voltage. Voltage is very similar to water pressure. If I have a piece of 1-inch pipe full of water and it's just sitting there static, there's no water flow. I have to have pressure built to push that water down the line. I have to have voltage to carry the energy down the line to shock the cow or horse or neighbor's kid or whatever. Ohms, if I'm not careful, ohms can get me in trouble. Ohms is a measure of resistance. That's just like old galvanized water pipes that were so common back in the 50s and 60s. They'll get corroded and scaled up inside. When those water pipes get corroded and scaled up, it slows down the flow of water because there's resistance and friction. The same thing can happen on my electric fence. If I've got a bunch of poor, junky, corroded, rusty, loose connections made out of materials that should have been replaced 20 years ago that probably weren't even intended for electric fence to begin with, that will slow down my flow of electricity. Theoretically, I want 0 resistance, 0 ohms on my fence material, my fence wire, and I want my insulators to have a high number of ohms, very high resistance. I don't want them to conduct electricity. My fence wire, yes, want it to conduct. I want 0 ohms. Never get there, but I want 0 or as close to 0 as I can get. Insulators, things like tree limbs that fall on the fence. I hope the tree limbs are a high ohm, a lot of resistance, and not going to conduct. And for the most part, yes, you can have tree limbs fall on a proper built fence and still not lose much voltage through that wood material, even if it's saturated. Joules, it's 1 watt per second. You can read all about the technical in your handout. Power supply options, 110 volt plug in the wall is always the cheapest because we are buying horsepower, right? We're buying joules. I can always get more joules for the dollar if I use a 110 volt plug in the wall. Now, what we tend to do is we want to take the easy route, the convenient route. And we go and we see a solar fence charger sitting on the shelf of the farm store and think, I've got about $250, $300 that I've budgeted for my fence charger. And I can get this solar that's sitting there ready to go. Just got to plug the battery in. Probably not going to read the instructions. It says let it charge for 2 days first before I plug it in. But anyway, as farmers, we don't read instructions. So I can pick up this $250 solar, stick it on a T-post. I'm ready to go. Or I can spend $250 on this plug in the wall, and then I gotta go find my Romex cable in the tool shed that I had left over from the wiring job I did in the tool shop 20 years ago and use that. No, we're not going to do that. We're going to go buy actual electric fence lead out, right? Nobody here is going to use Romex. That's the kind of things they do in Tennessee, Miss Swihart. I'm sorry, but it's so all these inconveniences that I see with a 110 volt charger, it's second nature to pick up the easy option. That's the solar. However, remember, when you buy a self-contained solar unit with the battery already inside of it, and the solar panel and the built-in regulator and all the extra features, you're going to pay 4 to 5 times more per joule. So for that $250, I'm getting the equivalent of about a $60 plug-in-the-wall Energizer. Ooh, them solars are high. Absolutely, yes, they are high, especially If I'm going to get the same power that I can buy on a $250 plug in the wall, if I want solar, if I'm limited to solar only, then I better be prepared to spend about $1,000 for a solar setup to get the same power that I would for that 250 on the plug-in. And I understand not everybody can use a 110 volt plug-in on their farming operation. You don't always have a tool shed or power service, or maybe it's lease ground with no power available, or the tenant won't let, or the owner won't let you use their electricity. So keep that in mind. Always be prepared to spend more on your solar. Power consumption wise, while I'm on that, we're on the new technology, and new, I'm speaking of last 20 years, you're looking at pennies per day. Pennies per day is what an electric fence box is going to pull. And I've got, in my house right now, I've got a 58 joule Energizer and had a 100 joule Energizer for a little while. And my shop is on a completely separate power meter than what our house is. And when I had the 100 joule running for 6 months or so, never even noticed a budge in the daily kilowatt usage, because I look at Penny Rile Electric's app about every 3 days to see what the chart's doing for the house and the shop both, and never budged it. So we're talking pennies per day, because it's a matter of watts, less than 60 watt incandescent light bulb for sure. So how does it work? How are we on time, Chris? Chris Shaw's clock's got me worried. Okay, I'll be finished in about 30. So how a fence works. We have an all hot system option. We have a hot ground system option. The way both of these work is the animal will complete the circuit. So in the all hot system, which is what I prefer, I've got, in this example, 3 strands, all electric, insulated. I've got an Energizer, and I've got a ground system. Old cow walks up to the fence, touches it with her nose. The power immediately flows down through her nose, down through her body, through her feet, through her ground rods that she's walking on, back through the soil to those 3 ground rods, just like UK and NRCS recommend at a minimum. And now I've completed the circuit. 2 things are happening there. Cow body, soil. That completes the circuit. If the cow jumps up in the air all 4 feet, does the cow get shocked? No. Bird lands on the fence, bird doesn't get shocked. Unless the bird touches something that's grounded next to it, then that's probably going to be a bad day for the bird. So we're relying on the soil. We can get away with this in most states east of the Mississippi River, using the soil to conduct the electrons. The alternative is a hot ground system. I'm pretty sure I'm up to 3 true hot ground systems that I've seen in 15 years in the eastern U.S. True hot ground systems. So for a true hot ground system, in this example, there are 3 strands, 1, 2, 3. Top strand, bottom strand, connected with this red wire back to the hot of the Energizer. Those 2 strands are hot. Now this middle wire, in this example, is a ground wire. And we see a lot of it. Oh, Barron County is good about this. Barron County's full of multi-strand high tensile fence. 5, 6, 8 strands. And we'll see insulators on 2 or 3 of those strands. And you say, what's those other 3 strands? Oh, those are ground wires. Right. Okay, because I'm sure they are connected every time you go under a gateway for a true hot ground system. You got to go under the gateway with hot, under the gateway with ground. All the way back to the Energizer ground system. Those ground wires, for them to be effective, have to be connected in a continuous current, no exceptions, for this true hot ground system to work. We know this 100% because once we get in the far west, in the desert areas, we have to do this. There's no choice because of the soil composition, the mineral composition, the lack of rainfall. If those folks don't build a true hot ground system, then they're history. They might as well have 3 strands of barbed wire keeping their cattle in, because out there, when those cattle get hungry looking for sparse vegetation, they're going to go somewhere unless 7,000 volts stops them. And they're not going to be able to get the 7,000 volts unless they touch the hot wire and the ground wire, which are both connected to the Energizer hot and ground using wire, not soil so much. It's an instant shock. True hot ground systems are very, 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 very effective except we don't have to use them in the eastern U.S. because of our soil composition and rainfall. You can. If you do it, at least build it right where you're doing something for a reason. And that's one of the things that we try to get you to think about at the fence schools is, why do we do some of the things we do when it comes to fencing? Is there really a reason? Or is it because we saw the neighbor do it and he saw somebody do it and somebody once a long time ago said, oh, this is the way you build fence? And so think about what we're doing. The reason I don't like a hot ground system is a lot of that's, from my experience, goes back to the ice storm. Barron County had the ice storm in '09, right? Same, y'all got it. Didn't get as much as we did in West Kentucky, but you all had some ice '09 or '08, big mess, huge mess. On my farm, we were without power for 14 days, without water for 21 days. That was interesting. So we were without power for 14 days. I had tree limbs down all over the place. I took a solar Energizer for a backup, went to my cutout switches, cut off a few places of the farm because my solar is not going to do the whole farm, and I was able to get power back on my fence even though I had tree limbs mashing 2 or 3 strands together in cases. All hot, it did not matter. It had 3 or 4 hot strands touching and some tree limbs that are not very conductive. If I would have had a hot ground system, and I have a tree limb fall on that fence overnight, and I mash the hot to the ground, I might as well take a screwdriver and go hot to ground on the Energizer, because that's what I'm doing in a true hot ground system. If it's not a true hot ground system, it's basically not doing any good. A lot of contractors say, oh yeah, I'll build you a 7-strand fence, make 3 of them hot, and 4 of them, they'll be ground. I'll drive a ground rod over yonder and over that hill, and it'd be a ground, it'd make your fence more effective. Well, actually, the contractor's probably trying to save money on the already 3-cent insulators that he's using on the fence. So think about that. What good do those non-electric wires do on your electric fence? Do they hurt? Yes, they hurt, and I'll show you why in a second. So grounding, what's the minimum? What's the recommendation from Extension and NRCS both? 3 galvanized ground rods, 6 foot deep, 10 foot apart. And you say, oh, I can't use a copper ground rod. Why can't I use a copper ground rod? Tool shed uses a copper ground rod. My house uses a copper ground rod. Why can't I use one? Well, you can, as long as you've got copper wire, copper rod, and a copper terminal on your fence charger. Then yes, if you can keep all 3 components together as copper, more power to you. But you're probably not going to find that situation. A lot of your terminals on your fence charger are going to be galvanized, some stainless now. Never, ever, ever mix 2 different types of metal together and run electricity through it. And why, as farmers, we do the opposite of what science and the engineers in the back of the room tell us, I'll never know. Because I know if I mix my copper ground rod to a galvanized wire, I will get electrolysis. I will get corrosion. It's electrical theory. And I guess it could be electrical principles, wouldn't it? Is that the right term? Anyway, don't do it, because it'll corrode and your fence won't work, and then you'll be mad. Don't take a copper ground rod and a copper wire and chuck it up in your galvanized fence terminal. Want to guess why? It'll burn it right in two. Jeff, how many ground terminals have you replaced in the last 10 years? You've seen some burn up. And you know what's burn up probably? Because somebody had a copper wire chucked up in a galvanized or a stainless terminal. 2 dissimilar types of metal with electricity running through it will corrode. Now you can go get all these special creams and salves and concoctions to put on there like the electricians would use, and if you want to go through that trouble, or you can just do what we tell you and recommend because we know it works, and do galvanized ground rods, galvanized wire. The ground system of your electric fence is there for function. The ground rod on this building is not here for function. And wherever Chris's box, his electric box is, that ground rod, I can go cut the wire on it and the lights will stay on. That's for safety reasons. So, all right, resistance, and am I good for 3 minutes? Okay. All right, 3 minutes. So I'm going to drive the point home about why all of this 7 and 9 strand Barron County fence would be more effective if all 7 or 9 were electrified instead of just having 3 or 4. So multiple wires carry more power for longer distances. And if we look at the ohm rating of 1 strand of high tensile wire, We're at 56 ohms per mile. The larger the wire, the more power I can carry. That's why the 17 and 16 and 14 little skinny steel wire, that's why livestock a lot of times don't respect it. It doesn't carry much power. Water in a pipe. Big pipe carries a lot of water. Little water hose, not a lot of water. So bigger wire carries more power. 56 ohms per mile. We want 0, so we're getting close to 0. We're at 56. If I take 2 strands of high tensile wire, join them in parallel at that brace assembly up and down, and go to this brace assembly and join them up and down parallel, I now have 28 ohms per mile because I've got not this much steel, but I've got this much steel carrying the power. It travels around the outside. So what if I had 4 strands of high tensile? If I do the math, according to the electrical engineers, I have 14 ohms per mile of resistance. I'm getting closer to 0 every time I add a strand, add a strand, add a strand. What if I had an 8-strand fence and 4 of them are electrified? I'm leaving 1/2 of my potential sitting there for no reason. Unless it's a true hot ground, all 4 of those connected together all under every gateway back to the ground rods that's connected to the Energizer. That's a different story, but I don't see that much. So more power can be carried for longer distances with more wire. Don't mix metals. Don't take shortcuts. Don't do silly things and expect good results. Don't use house wiring. Don't use copper mixed together. Low impedance fence chargers can do a lot of things. They can't perform miracles. Don't expect it to shock through pokeweeds and honeysuckles and thickets. You're going to have to do some bit of maintenance. Maybe not go out there and weed eat it or spray it every week. How effective is this? We'll talk about that later and make about half of you mad, I'm sure. But those little doodad insulators that are about that long and they short out, and if you don't believe it, go out there at nighttime after they've been up for 10 years and listen to it. The wraparound insulators. There's a case here where a fellow had a wraparound and it shorted out, so he put the cheapest insulator he could find, and then there was some back pressure and it cut that insulator in two. So don't use poor quality products. In Kentucky, with these wraparound jobs in Kentucky, as of 2018, if you are using taxpayer money on an EQIP program for electric fence and you use a wraparound insulator, then technically, according to the 382 fence specs, it is not an approved component, because NRCS in Kentucky believes that if you use the wraparound tube insulators, you're not getting the lifespan out of your fence using the money that they provided you to build that fence with. And they just reinforced it again in September 2020 with the latest CPS 382 spec. So don't use, I probably shouldn't even comment about this. That fence did not work very well. There's a lot going on there. We'll talk about bracing later. Josh is going to catch us up on what the future holds in technology. I'll give you a little primer into it with some of the things we can do now. As farmers, a lot of us have been forced to move to the technology age with these things, and we like to have a lot of control in our fingertips on what's going on our farm. Now, very easily and very, very economically, I can have my Energizer sitting in Muhlenberg County, Kentucky, and take my iPhone with an app on it, turn it on and off, look at a graph of all the different spikes and voltages. I can also get alerts when my voltage drops down below whatever level I set it at. I can have 6 different monitors around my farm and know exactly what the voltage and amp draw is on the back next to the creek or the other side next to my neighbor who's always throwing trash on the fence. I can tell when the fence shorts out. I'll get an alert on my phone. And then I can call my wife and say, go fix the fence there if you don't mind. And she'll usually reply back with something that's not too. So anyway, technology, there's a lot of technology behind a lot of the things that we talk about. There's a reason behind some of the madness. We'll have plenty of time in the field to answer questions. And I'll leave you with that. And that just happens to be a cow wearing a collar that talks to a GPS base station in the middle of the field that talks to satellites that can be controlled by an iPhone. What about all that land in the West that has just burned up for about the 100th year in a row? What if that land could be grazed without being fenced? What about all the coal mines in East Kentucky that can't really be fenced easy because of terrain? What if it could be geo-fenced? how much more could we utilize? So that technology's here and being developed now and has been developed. So anyway, save your questions for the field. I don't want to jump into Josh's time any more than I have to. So I will see you out there.